In today's lesson, we're going to take a look at standard WE3 potential energy. And what potential energy is potential energy that is a type of energy that's stored, that is stored for the time being, that can be used later. When we talk about potential energy is directly related to how a system is either configured or the positioning of the system. So if you think about potential energy, maybe like a rubber band being stretched or a rock or a stone being held up a certain distance over the ground. The thing about potential energy is a type of energy that can be converted into a different type of energy. So its potential is the potential to become something else, like kinetic energy or heat. In this class, we're going to study two particular types of potential energies. There are others, but the ones we're going to look at in this unit are going to be gravitational potential energy, and that's the energy associated with the position height-wise of an object, and elastic potential energy, which is the energy stored within different elastic materials like rubber bands or springs when they stretch. So with that being said, let's talk about this first type of potential energy. This is going to be gravitational potential energy. The gravitational potential energy is dependent on the height of an object relative to how far it can fall. That is how much potential energy is dependent on that. Different things that have potential energy are anything falling, like water over water bridge, waterfall, a suspension bridge, a snowflake going to fall. Anything that is high above the surface over which it could fall to has a certain amount of gravitational potential energy. When you have gravitational potential energy, an object gains its potential energy when it's lifted to a higher elevation. When you talk about this gain in potential energy, gravity is going to be doing work on the system, so you have to put energy into it, the work to lift it. That work into it by work energy theorem is what's going to get converted to the change in energy or increase the potential energy. So when we talk about potential energy, it depends on not just the height it's going to be, but also the mass of the object. So there's two things that it depends on: the mass of the object and the height it reaches. For gravitational potential energy, we have an equation, and it says that the potential energy is equal to mass times acceleration due to gravity times the height. So those three terms, mass times gravity times height, will tell us how much gravitational potential energy is in a system, and we have those terms that we are all familiar with. Let's go ahead and do an example of this. So when we have a 5 kilogram mass lifted from the ground to a height of 10 meters, I want to figure out how much gravitational potential energy that mass has at that height of 10 meters. So looking at the things the problem has given us, they tell us mass is 5 kilograms, the height they're lifting is 10 meters, and we know acceleration due to gravity is 9.81 meters per second squared. So we want to find potential energy, so we're going to use the potential energy equation, mgh. Plugging in our values, 5 times 9.81 times 10 will give us a total potential energy of 409 joules.